Welcome, this is the Module 2 Review Packet Solutions. We're going to be going over Part 1 all the way to Part 4, which is just the first page of the review packet. Right here, what we see is Isaac starts a race at 500 meters and he wants to start covering more distance at a rate of 5% per minute. You're going to write an explicit exponential function to model Isaac's running speed. You're going to use t for time and pt for the value of the item. Okay, so we see here that he starts to run at 50 meters. So that's going to be your zero term. That's f of 0. And your r is 1 plus 0.05. It's 1 plus because he's covering one more distance. And the 0.05 is the decimal of 5%. 5% in decimal form is just 5 divided by 100, which is 0.05. This is my equation for the zero term explicit for the exponential function f of 0 times r to the power t. Plug into the values, I get 500 times 1.05 to the power t. What is your distance after 3 minutes? You're going to let t equals to 3. That stands for 3 minutes. You plug that in. It's 500 times 1.05 to the power 3. That should be roughly around 578.8 meters once you plug that into the calculator. C. Isaac decides to look up a competitor's race time online and find this information. Here, at 1 minute, the runner is at 500 meters. At 2 minutes, the runner is 525 meters. And at 3 minutes, the runner is 550. He believes this can be modeled by a linear function. Do you agree or not agree? Please explain. I would say yes, the model is a linear function because there's a constant rate of 25 meters for every single 1 minute that has passed. So notice 525 subtract 500 is 25. That is how I'm getting the 25 meters. I'm computing the common difference to show that it is a linear function. Number 2. Isabel initially has $6 in her piggy bank. She wants to start saving more money, so on each day she puts $2 in her piggy bank. You're going to write the explicit linear function. So what we have here is our zero term, which is 6, because the scenario says Isabel initially has $6. The common difference here is 2. It's positive 2 because she's putting $2 more in her piggy bank. Write down the linear equation. Please notice the linear equation looks like y equals mx plus b, but in this case, the m, which is the slope, is going to be replaced with the common difference. The x is going to be replaced by the t, and the b, or the y-intercept, is going to be replaced by the zero term. Okay, you should get y equals 2t plus 6, or that's how this one looked like in function notation. How much did she save after 30 days? After 30 days, that means let t equals to 30. Plug in 30 in for t. 2 times 30 plus 6 is just 66. So she saved $66 on her 30th day. C. Isabel friend is also saving up money and records her findings. So the units are off, but it should still be 2, 6, and 8. Okay, it should be days and month amount of money. Okay, she believes this could be modeled by an exponential function. Do you agree or disagree? I would actually agree, because the exponential function, because there's a common ratio of 3, or you can say increased by 300%. Part 2, it's a multiple choice. What is the growth ratio of an exponential function curve which passes through the point 0, 2 and 5, 486? To make it simple, I plug it in a chart to see. What I'm doing is I'm building off each y term based on the recursive. So it starts at 2, then the next one is going to be 2 times r, then it's 2 times r squared, then 2 to the r cubed, because r is being multiplied over and over again. So my fifth term, 2 times r to the fifth power equals 486. Okay, that's rewriting the equation. Divide 2 to both sides, you get r squared equals 243. The inverse of the exponent is just taking 1/5 of it, 1 of whatever the exponent is. In this case, it's 5, so it's going to be 1 over 5 is the power. So if you do 243 to the 1/5 power on your calculator, you should get 3. Okay, so 3 to the 5th power is basically 200. Right, will get you that. Okay, so R is basically 3, so the answer would be B here. 2. What is the growth ratio of an exponential function curve which passes through these points 0, 5 and 2, 7 to 720? I make my chart. My zero term is 5. My first term is 5 times r, and my second term is 5 times r squared equals to 720. Rewrite the equation, divide by 5, get r squared equals to 144, square root or take it to the power of 1 half. You should get 144 to the 1 half power is just 12. Basically, the square root of 144 is 12. Okay, 3. Here you have a online bidding store which records and track a purse that was auctioned off. Select all statements that are true. Was the initial bid 60? No, the first bid is 60. Okay, that's number 1. The initial bid was probably 55 because that is the 0x value. Okay. The online bid of the purse increased by $5 for each bid correct. From 60 to 65, you're increasing it by 5. From 65 to study, you're only increasing it by $5. Okay, so that's the only one that was correct. The relationship between the bid number and bid amount is continuous. That is false. It is discrete. Look at the graph. It's each point. And the last one, the bid amount is 100 at 10. Nope. It would be 105 at the 10th bid number. Okay. The cost of renting a movie on Redbox is recorded on the table. Select all statements that are true. The relationship of nights rented and total cost is linear. That is correct because they're increasing by such an amount each time. A constant amount. The constant amount is number 2. Online bidding for the purse increased by $1.25 for each night rented. It should be total costs of the movie increased by $1.25 per night. That is correct. The relationship between the nights rented and the total cost is discrete. Yes, it looks discrete. It's not continuous. It's finite amounts, right? The total cost is $13 on the 10th night rented. No, that would be wrong. It is 12.75. It's $12.75 on the 10th night. Part 4, you're going to determine whether the relationship being represented is linear, exponential, or neither. Indicate your answer by selecting on the appropriate box. The first one, the smiley face, it starts by 4, then go to 6, then goes to 8. It seems like it's increasing by 2 each time, therefore it is linear. A volleyball tournament begins with 128 teams. After the first round, 64 teams remain. After the second round, 32 teams remain. Seems like it's being cut by it's being cut in half each time, okay, which is being multiplied by r equals to 0.5, okay, and that is basically exponential. The total number of babies born in each country each minute after midnight can be estimated by this sequence, okay. It seems like it's increasing by 5 total babies for every single minute that passes, so that is also going to be linear. The next one, the website days and the amount of members on that website. It looks like the website is growing at 325 each time. So that's also linear. Notice every single linear has a constant rate of change, or constant slope, or constant common difference, whichever one makes sense to you. Okay. All right, part 5. Okay. Oh, nope, that's it. We're going to cover part 5 in the next video.